continuing the 2016 November paper, and the question 6, you should have a hang of it now already. Or in paper 1, almost always they have this question in of simultaneous equations. So question 6 says solve these simultaneous equations. And I've told you, and I'll tell you again, the easiest method to use is the method of elimination, almost in all cases. But then you should know all the other methods. The other methods are substitution and matrix method, and then the graphical analysis method. So we're going to use elimination method here. The first thing that we realize is that the coefficients for x, they're 3 and 4. So that means to make them match, the lowest common output would be 12. So we'd have to multiply this by 4 and then this by 3. But then we can simplify the process by just matching the coefficients for y. So already we have 2 here. Of course it's -2, but I'm just saying the numbers. The numbers, there are 2 here and then it's 1 here. So we can match this one very easily by multiplying one equation instead of 2. So what do we multiply this with? Multiply by 2. And this other one, of course, we just leave it like that, so by 1. So you get 3x minus 2y equal to 9, and on this one you get 8x plus 2y equal to 2. So you're multiplying throughout. So you're multiplying this and this and this, and then you figure out what to do. You figure out what to do here. Should we add? Should we subtract? So whenever you have different signs, simply add. Whenever you have same signs, simply subtract. Okay. So when you add this, you get 11x. This one and this one, they cancel out, and then here you just get 11. And then you divide both sides by 11. What do you get? You get x equal to 1. But then you're solving simultaneous equations, so you must have the values for both x and y. Here, this is another critical point. Take note of it. You have to choose the equation. You don't have to, but then it's better for you to choose the equation that solves for y the fastest. So it'd be the second one. Why? Because y is already isolated. Here you'd have to divide again by 2 and maybe shift it to this side and all that. You don't want to do that. You want to simplify the process. So you'd get this one. First write it out. So our x value is equal to 1, and then you get 1 minus 4, which is equal to -3. So I hope you're happy. This one will be our value for y. Okay, so that's it for question 6. I hope you're happy. Let's move to question 7. Question 7 says convert this in degree and minutes. Okay, in case you don't know, degrees, minutes, and seconds is just a notation that we use to present angular notation. So there are 60 minutes for each degree, and then there are also 60 seconds for each minute. Okay, just like similar to what we have in clocks, but then we'll be using angles for this. So we have part A, we have 61.7 degrees, and then just isolate out the degrees already, and then this one will be 7/10 what degrees. Just isolate out this one, because this part we are not going to touch it in any way. This one, 7/10 degrees, means 7/10 times 60 minutes. Each degree is 60 minutes. How you represent minutes? You represent minutes by the thing that looks like a complement. So you get 61 degrees plus, this one cancel, 42 minutes, like this. So you'd have 61 degrees, 42 minutes, and then you're done. Okay, and seconds we represent, this is 2 seconds. Okay, seconds and in angles. So this is it, and then you're done. So the first thing that we did was to isolate out the number of degrees, the whole number, and then we changed this one into a fraction. If you don't want, it's still okay. You can just say 0.7 degrees, but then you have to multiply this by 60, because 60 for 60 degrees, for 60 minutes per degree, and then they'll cancel out. You get your stuff in minutes, and then you just combine them in a single line, just like this, and then you're done. So let's move to question B. Question B, I want you to be careful with it again. Whenever you have mixed fractions that you're supposed to manipulate somehow, it's always better to change them to improper fractions. So here we just say 3 times 11, you get 33, 33 plus 2, then we get 35. So we have 35 over 3, and then whenever you're dealing with units, I advise you to write them in fractional, in the form of a fraction. And then now, see, you want to change from minutes or from meters per second to kilometers per hour. So we need to find ways to introduce kilometers whilst at the same time cancelling minutes. So these are called conversion factors. Okay, so we need kilometer at the top. So kilometer, the equivalent would be 1000 meters, like this. So there is the conversion factor would be 1 kilometer per 1000 meters. So this one would be your conversion factor. This one would be your conversion factor 1. And the reason we wrote it like this is so that these meters, they can always cancel, and then you're left with kilometers. We still have the seconds, so we can remove them in one step again. It would be what? We need the seconds to be at the top. So it would be 3600 seconds per what? Per hour, just like this. Okay, see how this will play out now. The reason I was telling you, let me show you how this will play out. This meter you cancel with this meter, this second you cancel with this second, and then we're left with kilometers per hour. So that's how you know that you're doing the right way, the things the right way. So here I'm just cancelling out stuff. 5, 7 here, 5, 2 here, then 3 here, then 3 here, then 6 here, then you get 42. So it'd be 42 what? Kilometers per hour. So again, you had to write what you're given. This 1 meters per second means meter divided by second, just like this. And then we introduce the first conversion factor for the distance, and then we introduce another conversion factor here, the K2 factor for the time. And the reason why we're doing this is so that you know that this cancels with this, because sometimes most students, they don't know how we're supposed to multiply by 1000, how we're supposed to divide by 1000. There's a method to that, and the method now is you use conversion factors, and you also observe the units. Students who are doing physics will be familiar with this, but if you're not doing physics, just try to remember your conversion factor for length and also for time, so that you can interchange, and then just observe the units. So let's quickly move to question 8. Question 8, we have a function, so we are asked to find f of -2, given that f of x equal to this. This one, it's like you can think of it as a mathematical calculator. Okay, so it inputs the value of x. Whenever you input your value of x, you actually get the value of that. If we put 1 here, you actually get f of 1 by computing on x. You're putting 1. So here we're supposed to put 2. Let me just repeat it real quick. Repeat the statement that we're given. We need f of 2, and even if you're not familiar with this, what you're supposed to observe was that this is f of x, and then where there is x there, put -2 here. So do the same, put -2, and whenever you're substituting, my advice is always use brackets, especially when you're substituting negative values. Okay, so here you get 4 over 4. If you had not put brackets, then you would have thought maybe it's -4. No, it's not -4, it's 4 over 4. Okay, so here, and then here, don't write this as 1. It'd be sort of like redundant, because you'd have to subtract again this part. So you just put your common denominator, and then you just get 4 minus 5 here. 4 minus 5, it's equal to what? It's equal to -1. So you just get -1 over 4 like this. I hope you're happy. So this is how you work it out. Let's move to question 8b. Question 8b, we have this statement, this expression, and we need to substitute all those into this expression. My editor, I don't know what it did, but this one was supposed to be x here, so it was supposed to be y plus z to the power x. I don't know if it was written like that in the actual paper, but then this is how it was supposed to be, because we have this to substitute. Okay, so we need to substitute these values, so that's why we're using big brackets, so that our math, it's a little bit cleaner. So this one is -2 on y, then on z it's what? It's 5. So -2 plus 5 to the power x. X is equal to what? Is equal to 2. So you actually get some negative 2, okay, plus 5, then we just get negative 2 plus 5 here, right? And then port 2, and then you get 3 to the power 2 equal to what? Equal to 9. So 3 plus 3 to the power 2 equals 9. So 3 to the power 2 means 3 by 3. So we get 9 here. So find the number of sides of the polygon. The interior angle of a regular polygon is 144 degrees each. Okay. Each interior angle is 144 degrees, and you're asked to find the number of sides of the polygon. So there are two ways to go about it. I'm just going to quickly run through both methods. The easiest one would be, of course, to find the exterior angle first. So exterior angle would be, for a regular polygon, the exterior angle would be 180 minus the interior angle, which is 144 degrees. Okay, so here you actually get 36 degrees. After this, you would know that the total for exterior angles, this applies to any polygon, is 360 degrees. So this one is regular, so it means it has exterior angles that are equal, so it would be 36 degrees for each exterior angle, and then the number of exterior angles would be n, corresponding to the number of sides, would be equal to 360 degrees. Yeah, so this one would be degrees as well, so that you see when it cancels. So divide by, okay, let me remove here equals, I don't know why I put that there, but basically this one cancels, and then we get 10. So our number of sides equal to 10. So you can even conclude, since n was not given, you can say therefore the number of sides of the polygon is 10. Okay, so this is one way to go about it. Another way to go about it would be using the total sum. You can say total or sum. So using the, let's just say sum of the interior angles. If we use the sum of the interior angles, the general formula would be 180. It would be 180n minus 2, like this, would be equal to 144 degrees, right, for each exterior or each interior angle. That would be n interior angles. So if you want, you can even say let the number of sides be n, so that the examiner knows exactly what you're doing. So here you get negative 360, here you get 144, and then you put these ones to one side, so you get this minus 144 and equal to 360. So here you get 36 and equal to 360. Then you divide both sides by 36. You get n equal to 10. Okay, so you can even send 10 sides, just to clarify. So those are the two ways by which you can find the number of sides of a polygon. And then question 9b says state the number of lines of symmetry of the polygon. My editor don't know what was happening. So state the number of sides and the number of lines of symmetry of the polygon. So for a regular polygon, the number of lines of symmetry equals the number of rotational symmetry as well, the order of rotational symmetry. So for our case, we found n equal to 10. So the number of lines of symmetry would be 10 as well. This is true for any regular polygon. So for example, an equilateral triangle, it's a regular polygon. The number of lines of symmetry is 3, corresponding to the number of sides. For a heptagon, which is heptagon means 7. So the number of lines of symmetry would be 7, and it also, the order of symmetry as well would be 7. Okay, so that's it. Pentagon 5, order of symmetry 5 for a regular pentagon. Okay, so that's it for number 9. I hope you're happy. Let's move on to question 10. So question 10 says find the value of, we have the desert code said, so we have 3 square root of 2 multiplied by 5 square root of 2, right? Yeah, so this is equal to 3 multiplied by 5 multiplied by square root of 2 multiply by square root of 2. If things are under your square root, so this one you get 15. If things are under your square root, you can even put them there under the square root. So the way you do it is here, square root, these ones, they go under the same square root. So square root and square root, you can also say square root and square root, they cancel if the number here is the same, okay? But then let's just go about it the longer route so that you understand. So here you'd get 15 by 2 here. So you get 30. So you get 30. 30 would be your answer. So yeah, so this one, another way to go about it is you just say 10 to the power half times 2 to the power half, which is equal to 2 to the power half plus half, which is equal to 2 to the power 1, which is equal to 2. That's why we have 2 here, okay? So you get 30 at the end of the day. Okay guys, let's move to question 10, part B. So the first part says we're supposed to work out 6,782 multiplied by 65. We're given this, it's equal to this value, and then we're supposed to work out this. So how do we do it? Here you can see this is familiar. This looks a little bit like this, but then this part is different. So how we do it is we manipulate this to become a little bit like this, so that we can substitute this 440,830. So it's 6,782 multiplied by 0.65. This is what you're given, okay? So you need to manipulate it to become this. So you get 6,782. These are called non-routine questions. It means that there is no one way to work out, but then you just have to understand the concept. So 0.65 means 65 by 100, okay? And if these are multiplying, you can always regroup and then check the numerators separately. So like this, and then divided by 100, like this. So here, this value we know already. It's 440,830. Okay. So we want to divide this by 100. What do you get? This comma was here, so it shifts 2 places. So you get 448. So 4,408.30. And then we are done. So this is it. And remember that this one was supposed to be my editor. We got it wrong. This was supposed to be 6,782. Okay, and then we get this part here, and then we are done for the first part. Let's move to the second part. This one is supposed to be 6 point, not what's written there. So the second part says we're supposed to evaluate. This time we are dividing this part divided by 6.5. So again, we need to manipulate it to be a little bit like this. So just take what you're given and then make it divided by something here. So you're given 6,782 multiply by 65 equal to 440,830. Okay, like this. So here you can divide both sides by 65. Divided by 65. And then what do you get? These ones, they cancel. And then here you get 440,830 divided by 65 equal to 6,782, like this. But then you need 6.5 here, so you have to adjust that. How do you do it? You just multiply by 0.1 here, of which if you do that at the top, you also have to do it at the bottom as well. If you do it at the bottom, you also have to do it at the top as well. What you get here, you get 0.1. So let me just rub this part a little bit. So you get 0.1 for this 0.1 here. So you get 0.1 440,830, like this, divided by what? By 6.5, because 0.1 times 65, you get 6.5 here, equal to 6,782, like this. So here, this one we have to get rid of it, so that it comes to the other side. How do we do it? We multiply by 10. If If we multiply the side by 10, we also have to multiply the side by 10 as well. So I'm just going to use the space here. This one's the cancel, so you get 440,830 divided by 6.5 equal to this one. If you multiply it by 10, you get 67,820, and then you're done. Okay, so how we do it, they're just testing your ability to manipulate numbers. Here you have to create the 6.5, here you have to create the 0.65, and then here it's divided, so you have to manipulate your original to become a little bit like this, so that it's 6.5 here, as long as you stick to the math. So for example, if you multiply by 0.1 at the bottom to create the 0.65, you have to multiply also the top part, so that you retain the value. The value doesn't change. And here we wanted to get rid of this, so that we remain with only this part, which is similar to this part here. So if you multiply by 10 one side, we also have to multiply by 10 the other side. So that's how we got this one. So we're going to move to question 11 in the next video. So cheers. Thanks for watching.